Ancillary services need to be adapted continuously to the increasing complexity and demanded flexibility of modern electric power systems. In the traditionally regulated energy markets, ancillary services were usually provided by integrated electric utilities. The transition towards smart grids requires a transformation of the traditional energy markets from hierarchical-based power systems towards open distributed smart power systems. The smart grid integrates the operation of all connected users, electricity producers, users, and prosumers in order to ensure a safe, efficient, and sustainable delivery of electricity. Challenges related to the provision of ancillary services in smart grids are mainly due to the characteristics of these systems involving, among others, new types of market participants, renewable energy sources, and distributed energy resources. Market, business, and cost models related to ancillary services of smart grids require changes on the corresponding regulatory frameworks. Future smart grids and ancillary services will have two key components: intelligence and power electronics. Intelligence will come from innovative technologies applied to components and interfaces. Power electronics will be the enabling technology for future generators, loads, and energy storage-based devices. Future provision of ancillary services and new market participants. Ancillary services markets are nowadays open to a wide range of new participants, such as large-scale renewable generation and energy storage systems, grid-connected devices like power electronics, switched compensation devices, and providers of DERs including demand response, small-scale energy storage systems, and distributed VRE generation. A number of developments in recent years in demand-side response, together with an increased research into how to emulate the ancillary services capabilities of thermal generators with renewable generators and energy storage systems, have improved the ability of these sectors to meet requirements for ancillary services. Wind turbine generators and energy storage systems are capable of providing nowadays different levels of synchronous inertial response. Inertial response has been traditionally provided by large thermal generators and large hydropower plants. Although such frequency disturbances can be addressed using fast frequency response services, synchronous inertial response can provide a more reliable and faster response. Solar PV power plants and energy storage systems having power electronics interfaces with the electric power system can provide reactive power support. Reactive power helps to maintain voltages in the system within prescribed limits. Reactive power support is especially important when there is large generation in areas far from main load centers or connected to main load centers via a weak electric power system. Distributed energy resources such as rooftop solar PV systems, behind-the-meter energy storage systems, plug-in electric vehicles, and commercial and industrial loads can provide ancillary services to system operators through price-based incentives, often referred to as explicit demand response. By increasing liquidity and competition in the ancillary services markets, DERs can also help lower ancillary service procurement costs. DERs are allowed to participate in the markets independently or through aggregators or retailers, depending on the market design in place. Ancillary services and renewable energy. The expansion of renewable energy, especially wind and solar power, changes the requirements of the electric power system. Electric power systems are experiencing nowadays a large amount of renewable generation with highly stochastic, nonlinear, and partly unpredictable characteristics. This increase of variable generation in the energy production changes the demand and the ways of providing ancillary services and places new demands on the operational management of the electric power system. Grid integration of renewable generation requires ancillary services and at the same time has the potential to provide ancillary services to the electric power system. Modern renewable generators are able to provide many of the ancillary services that were traditionally provided by conventional generators or by other electrical equipment, adding an additional revenue stream for renewable generation plants. For example, wind turbines with variable speed generators have the potential to add synthetic inertia to the electric power system and assist in frequency support. Possible ancillary services provided by renewable generators: green G feasible, yellow Y possible with technical limitations and/or economic challenges, red are not feasible possible. Ancillary services and electric vehicles. Plug-in electric vehicles EV have the potential to become a key component in providing ancillary services for the electric power system. They can behave like distributed energy storage systems and have the potential to discharge power back to the electric power system through unidirectional controlled charging V1G for short or through vehicle-to-grid technology V2G for short. EVs have the ability to supply power at a very fast rate, which enables them to be used for providing several ancillary services helping to improve grid stability. Their power capacity is limited, thus, a single EV cannot provide these services for the period of time needed by the electric power system. However, when EVs are aggregated, they can complement one another, resulting in a virtual power plant with a fast response and the ability to provide ancillary services for the needed period of time. Smart charging and discharging of EVs can provide flexibility at both the system level and the local level. At the system level, smart charging could facilitate balancing in the wholesale market. With V1G, the EV charging patterns could be controlled to flatten peak demand, fill load valleys and support real-time balancing of the electric power system by adjusting the charging levels. With V2G, by injecting electricity back to the grid, EVs could also provide ancillary services to TSOs. Smart charging could also help DSOs manage congestion and end users manage their energy consumption. Ancillary services and energy storage systems have nowadays an important role in increasing the efficiency of the electric power system and ensuring its stable operation by their ability to provide several ancillary services in real time and, if necessary, independently from the electrical grid. The main ancillary services provided by energy storage systems are related to regulation and reserves. Regulation services are used to balance electricity supply and demand on short notice. Reserve services generate additional electricity used to compensate capacity loss due to the unexpected unavailability of power generation. Additional ancillary services have become recently more viable as the costs of energy storage systems have decreased and energy storage becomes a more integral component of the electric power system. Ancillary services have provided a foundation for emerging energy storage technologies in several markets around the world. These services are attractive for developers of energy storage projects as they often have either structured contracts or well-established competitive markets that provide a reliable source of revenue. There is an increasing number of energy storage technologies available in the market that can be used to provide ancillary services. Reducing the barriers that energy storage technologies face to become possible participants of ancillary services markets will help developers to obtain additional sources of revenue for different services provided, enabling financial feasibility. Ancillary services and grid codes, as the electricity generation capacity continues to increase globally, including a higher share of renewable generation, and more nonlinear and other challenging loads are connected to the electrical grids, stricter requirements regarding grid connection, operation, and balancing of generation renewable or non-renewable and consumption loads are introduced by TSOs and DSOs to ensure that electric power systems remain reliable and robust. These requirements are compiled into grid codes. Grid codes typically include the necessary ancillary services and power quality improvement capabilities that facilities have to comply with in order to achieve grid code compliance. Power system ancillary services and the smart grid are crucial for maintaining a stable, resilient, and efficient power grid. Ancillary services include various support functions that help balance supply and demand, control frequency and voltage, and ensure quick recovery after disruptions. These services are essential for integrating intermittent renewable energy sources, like wind and solar, which require fast response balancing to maintain grid stability. The smart grid, on the other hand, represents a modernized electricity network that incorporates digital technology, real-time monitoring, automation, and two-way communication. It enables the grid to be more responsive, reliable, and efficient, allowing utilities to detect issues in real time, optimize energy distribution, and incorporate renewable energy seamlessly. Together, ancillary services and the smart grid enhance energy efficiency, improve resilience against outages, and support a more flexible and sustainable energy system.